What I'm going to do is I'm going to read, all right?
High school, Michelle speaking. This is the main office. Who?
I don't know. All I heard was humming.
Yeah, she didn't mean to do that.
Yeah.
She was on the phone. She was trying to answer the phone.
Okay. Hello again. Okay. Got my new hat on. My new vest.
Cool?
Am I trying to be cool?
Yeah.
I simply don't try. I am.
Oh, sorry, Mr. Darcy.
I am a Jedi Knight of cool. There is no try. There is only do. There is only is. There is no.
There's only is.
Right? Understood? There only is. Yes. Now, so let me just read the last one we did. We were talking about before we were cut off. I ran out of space. So let me. It said on a summer day at the equator on Mars, the temperature never rises higher than 50 degrees Celsius. Find this temperature in degrees Fahrenheit in order to determine if this world would be a comfortable temperature for humans visiting Mars. Now, that was the problem. And remember, I did 500 degrees, and I converted it to what? You remember? What did I convert it to? Was anybody taking notes?
500 degrees.
I did 500 degrees. Multiply 500 by 1.8 plus 32.
It was 932.
932, okay? So, and that was a mistake, but 932 degrees.
Boys track, meet on the bridge at 2:45, please. Boys track, please meet on the bridge at 2:45.
What was I saying? Yeah, 500 degrees Celsius is 930 degrees Fahrenheit. And that's exactly what I did, correct?
Yes.
Now, this is the deal. But on Mars, the problem actually was not 500 degrees, but 50 degrees. Now, how do you know automatically if 50 degrees is hot? Well, this is the temperature that I always remember. I used to live in Spain. 37 degrees is normal body temperature. You take a thermometer. Well, you guys don't do that. You don't have glass thermometers anymore. Have you ever used one?
Not really.
In glass thermometers, there's a little arrow over 98.6, okay, which is normal body temperature. But in Spain, when I lived in Europe, the arrow is over 37 degrees, which is approximately normal body temperature. So 38 degrees is about 100 degrees-ish, right? So you know 50 degrees is hot, and indeed it was. Multiply by 9/5, add 32, it was 122, yes. Correct? So that's really hot, okay. And I think I was saying that that's what it's going to be like in the Middle East, Abu Dhabi, when I go there. Hopefully it's not going to be that hot, but maybe in the sun it will be that hot. Anyway, this next problem that we're doing, exercise 6 on problem set 11, reads as follows. It says, Leah is building an aluminum roofed shed in her backyard to store her garden tools. The flat roof will measure 2 meters, about 6 feet-ish, a little more than 6 feet, by 3 meters, 9.5 feet. So it's a pretty big roof, don't you think? The flat roof will measure 2 meters by 3 meters in an area during the coolest winter months when the temperature is negative 10 degrees Celsius. But the temperature in Leah's neighborhood can reach as high as 38 degrees Celsius, which is approximately 100 degrees, right? If 37 is 98.6, 38 is pretty close to 100. What is 38 times 1.8 plus 32? They're Americans. They don't have any idea of Celsius.
100.4?
100.4, so it's pretty close. Okay. So Leah's neighborhood can reach as high as 38 degrees Celsius. What is the area of the roof that should stick out from the shed in the summer so that the roof just fits the structure during cold winter nights? right? Shall I read that again?
Yeah.
Let me read the whole problem again. It's a little weird.
Okay.
Okay? It's an area. It's 3 by 2, which is 6 square meters, right? Okay, but let me read the problem again because it's a little weird. Leah is building an aluminum roofed shed in her backyard to store her garden tools. Easy. The flat roof will measure 2 by 3 meters in area during the coldest winter months when the temperature is negative 10 degrees.
Effie, if you're in the building, could you call the main office? Effie, if you're in the building, could you contact the main office, please?
So at negative 10 degrees, it's going to be 2 by 3. That's at negative 10 degrees. It's going to be 2 by 3. You see that? You understand now? So you got to build a frame. But how big do you want to build the frame? Don't you have to build the frame farther out so the roof has room to expand, correct? And that's what they're asking. So then it says, Leah's neighborhood can reach as high as 38 degrees in the summer. What is the area the roof should stick out from the shed in the summer so that the roof just fits the structure during cold winter nights? Aluminum, the alpha for aluminum is 24 times 10 to the negative 6th, okay? Its area, this is the key, you ready? It's area, expansion area, not length, but area, but you use the alpha. You use the coefficient of linear expansion, even though it's area. So you use the coefficient of linear expansion for linear expansion problems and area expansion problems. You use beta only for volumetric expansion problems. Clear? All right, so the difference is this, that the area is 2 times the area. You see that? Because it's length and width. So you have to apply that linear expansion twice. Clear? Yes? Okay. So it's going to be 2 times the area. So it's going to be, the area is going to equal 2 times 6. I'm going to leave off the unit labels. Is that okay?
Yes.
You sure? All right. Expansion, linear expansion, uses meters. Okay? Volumetric expansion uses cubic centimeters. But this is meters, so everything's in meters, so we're cool. Okay? Times alpha, that's per degree Celsius, right? And it goes from negative 10 to 38. So you want the total. You want the absolute difference, the absolute change, right? Correct?
Mm-hmm.
So it's going to be what? 48, correct?
Yes.
Hopefully that's all in. Can you see that? All that? Okay. All right? Yeah, I get a little leeway. Okay. So what is delta A therefore? What is 2 times 6 is 12. 12
I got a decimal.
times 48 times 24 times 10 to the negative 6. Do we have an answer here? What's the answer?
0.013824.
0.0138. And that's going to be, now don't use too many significant figures because that knock on the door at 2 o'clock in the morning might be the significant figure police. So let's just use 2 significant figures. Let's use 3 the most. So 0.01.
Oh, yeah, 4.
No, 0. The first 0 is insignificant.
No, it's
0.0138. That's 3 significant figures.
After the decimal.
Yeah.
I don't remember. McCarthy.
No, there's no number on the other side.
What is it? 0.0.
138.
Yeah, that's 3 significant figures.
But that's 4 sig figs.
No, that's not significant.
There's no number besides 0.
Just those are
Anything after
significant.
I
Nope.
thought anything after the
Nope.
decimal.
If it only the 0 after the decimal, only if it's a final digit. In other words, that's 0 is significant.
Oh.
Yeah. But I don't really do significant figures.
Thank God.
It's absurd. It's
Very
one of the most absurd things in science when high school teachers spend 3 or 4 weeks on significant figures.
Yeah, I know.
Learn it along the way. What is a significant figure? Do they? 1, 2, 3, 4, 5, 6 people in this classroom took chemistry last year. Does anybody know where the significant figure comes from?
Nope.
What is a significant figure?
Just rounding, like rounding the
No, they
I
have
don't
no
know.
idea.
I have no idea.
You know what it is? It's simply any number directly read off an instrument. That's all it is. Isn't that easy? Right? Isn't that easy?
Funny.
So unless you have amazingly sophisticated instruments, why would you use more than 2 or 3 significant figures? Right? Doesn't it make sense, Jack? Okay.
Why do we go over it so much?
Because
Chemistry.
some chemistry teachers have nothing better to do. Did I say that out loud? Sorry.
Yeah, you
Okay.
did.
No names.
No names. No names. No names. No names. We're cool. No names. Okay. Are we done? Yes? So that's going to be the increase. Now wait a second. Hold it. It says, what is the area, what should stick out, right? So is that the right answer? So in other words, how much should it stick out? So it's going to increase that much, right? That much is going to stick out, right?
Okay.
So that's the answer. So what are they asking for? They're not asking for the total area in the summer. They're asking for just the increase in area, right? So we answered the question. What's the point? What am I trying to make? What point am I trying to make? I'm trying to make the answer should make sense relative to the question. Understood?
Yes, absolutely.
Laura's like, of course, absolutely. We're off.